This is activity LT91, and I want to show you how to use some intelligence into a part design problem. For example, suppose we have a structure or a part as shown on the right, and I have named the fillet radius RF, the hole radius RH, the length and the width of the block as L and W. What I want to do is to make sure that when the values of N and L and W fall in one of these four quadrants, the result is the information that's shown here. For example, if W is bigger than 50, let's say millimeters, and L is bigger than 100 millimeter, there should be no hole or no fillets present. If, for example, W is bigger than 50 and L is less than 100, then there should be a fillet present with a radius of 5 say millimeter, and a hole present with a radius of 10 millimeters, 5 millimeters, sorry. So this is the way this graph is interpreted. Now notice that on purpose, I'm avoiding W equal to 50 millimeter itself and or L equal to 100 millimeter. In other words, I'm staying away from these two lines, but I'll come back and make a comment about it as to why I did that and what is the effect of what I have done in case you plug in, for example, W equal to 50 or L equal to 100, see what happens. Okay, let's not worry about that right now. So we're going to go make a nominal part. Let me put my units to millimeters. So tools, options, parameters are units. It's already millimeters. Very good. Okay, so let's go ahead and do the following. Uh, uh, we're going to go into part design. I'm going to change the rendering to solid like that. Okay. So we are in part design. On that horizontal plane, I will sketch a centered rectangle just for the sake of simplicity. Try to minimize the amount of work that I have to do like that. And I'm going to dimension these because at the end of the day, these are things that we want to be able to kind of control. So dimension this thing and dimension that guy. All right, exit. And we're going to do a path. Okay. And these four sides, I'm going to do a fillet, an edge fillet. I'm going to select that, this edge, and that edge, turn around, this edge. I'll do them at the same time because you're assuming that these are the same radii. Okay, good. And for now, it's, well, let me make this thing, I don't know, maybe 7. It's just some random numbers that I pick. Then I'm going to make a hole. Let me hide this thing. Or let me collapse it. That's what I meant it. Okay. So then I'm going to put a hole up here. I can also do a pocket, but I will go with the hole. So here's the hole option. You click on the hole, you select that top face, and then I'm going to position it exactly halfway between. So position, let me see. I'm not sure if it's, maybe it's not quite at the center. We'll make it right at the center. You can see that it's not exactly at the center. That's fine. So here's what I'm going to do. Uh, that point, which is the center of the hole, control left edge, control right edge. I'm going to make that thing uh, equidistant from both sides. Let me try it again. Cancel. Normal view. Okay. So the left side, control the right side, control that center point. Can I make it equidistant? Yes, right there. And then top line, control bottom line, control that center again, right, equidistant once again. So notice that the center of the hole will be exactly at the center of the that uh, block. Okay. Well, let me make this thing all the way to the end, to last. Okay, it goes all the way through. That's okay. And currently there is a diameter of 10. I'll make it 15, diameter 15, just for the heck of it. Okay, good. All right. So we created a nominal part. Let's do a quick save. Now we want to introduce some uh, what is called intelligence into this. And what do I mean by that? I'm going to have to write a program. And oh, before I do that, I want to rename these parameters. So these are not intrinsic parameters, so that there is called RF and RH and L and W. So how do I do that? I click on f of x, which is the knowledge toolbar right there. You can see that, the knowledge toolbar. This is the icon f of x. And what I do is then click on the activity here, on this part. All the dimensions that are needed for me, by me, are listed here. So for example, I want to call this thing, this is the intrinsic name of the parameter that's created. Okay, so I want to call this thing W, big W. And then that guy, this is the actual intrinsic name in the Catia program. I'll call it big L. Okay. This is radius of the fillet. You can see that, fillet radius. I'm going to call this thing RF. Okay. And yep, apply. And finally, unfortunately for hole, it's the diameter, it's not the radius. So I can select this thing and I will call this thing DF, not RF. I'll call it DF. Okay. DF. So have to keep track of that when I write my code. Okay, good. So we rename the stuff. And what do I mean by rename? Again, you click on f of x and say, show me only the rename parameter, and it shows you the rename parameter with the current value, nominal values. Very close. Okay, so we want to write a program. And one way of doing it, you go to Start, KnowledgeWare, Knowledge Advisor, and here is how you write a program. It's called rule. You click on it. This is the name of the rule, so I can call it rule. Here I'll call it LT91 because this is the activity. I'll just leave the rest of it as it is. It's done by me on the 21st of March 2024, and fine. We say okay. So now I can start writing my program. Let me make this thing a little bit smaller. And I also want to bring this thing in the, let me move this thing up a little bit. Okay, my rename parameters are here. You can see that. So the program that I want to write comes from this. For example, let's go ahead. If parentheses, if you look at that, if L is less than 100 and if L is less than 100 and W is less than 50, there is no hole and the radius of fillet is 5. So I go here. If W is less than 50 millimeter and L is bigger, notice that I'm leaving out the equality possibility. 100 actually also less than 100 millimeter. If this happens, what do I want? Well, I want, here's what you want to be happening. So write the stuff in here. There is no hole. If there is no hole, what I can do is I can say, okay, first of all, click on the hole here, click on the hole in the tree right there, and say, show me all the stuff in the hole. Scroll down until you come across activity right here. hard body hold one activity. Double click on it. There we are. I want this thing, no hold means that this is to be false. False. And if it's false, you don't have to worry about the diameter anyway, whatever it is. Okay? But you want the fillet to be present. So just to be on the safe side, so I'm going to click on the edge fillet. Here is the activity. Edge fillet equal to true. Okay? Good. This is equal to false, not false. Equal to false. And over here equal to true. And the radius of the fillet, you are told that big RF you want it to be based on that graph that I showed you, that this chart, based on this chart that I gave you. This should be radius of the fillet is 5 millimeters. So I go here, it says equal to 5 millimeter, and that takes care of first possibility. Close that bracket, enter. If Now let's look at this region. If, for example, W is less than 50, but L is bigger than 100, this is what you want to be happening. So we go here. If W is less than 50 millimeter, and L is bigger than 100 millimeter, close the parentheses, millimeter. Close the parentheses, enter, and then bracket, curly bracket, right up there. So what do we want? Based on what we have here is no fillet. So activity for fillet is false, and there should be a hole. Okay, so we're going to say okay. For the fillet, there's a fillet, there's the activity equal to false, like that. So it's easier to read. False, enter. But the hole is on. So you go here, selected the hole from here, and then go find the activity for the hole to be equal to true. And if it's true, then I need the radius of the hole. Now, because we don't have radius of the hole, we have diameter of the hole. I'm going to write down diameter of the hole equal to 30 millimeter. Okay, so down here, enter. DF equal to 30 millimeter, and close the bracket, enter. Now let's go to this region. W bigger than 50, L less than 100. Oh, I forgot here. Whoa, 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 whoa. This is else. If, not if. Else if. Okay. Enter. Else if parentheses W is bigger than 50 millimeter and L is less than 100 millimeter. Enter. Curly brackets. So where are we now? We are in this top left corner. So we want both fillet and the hole to be present. So we're going to go here. For example, I select the edge. I say fillet to be present. So fillet to be true. Enter. We want the hole to be present. Click on the hole. Get the activity for the hole right here. This is also true. And if that's the case, you have to supply the values. So RF equal to radius of the fillet, according to what I have here, to be 5, and the radius of the hole, diameter of the hole to be 10. Okay, so the radius of the fillet is 5 millimeter. Enter. Diameter of the hole to be equal to 30 millimeter. Curly bracket, close the curly bracket. W is bigger bigger than 50 millimeter, and shooting myself in the foot by doing this the way it is, but that's okay. L is bigger than which one is it that you're doing? We are doing this case, right? Yep. Yes. Equal to 4. Yeah. So for the whole, it's going to be false. False. Close the bracket. And you go to next line. Obviously, this last situation is else. I forgot this. 100 millimeter. Close the parentheses. Else. Now, when you look at this, else means that W equal to 50 or L equal to 100. Okay, so here's the way I'm going to include it. That is, that is not specified in this figure, but I'm going to do that. So if either W is 50 or L equal to 100, which means none of these lines are correct anymore, I have to decide. For example, let's say that in this situation, what about making us the fillet radius equal to I don't know, maybe 15, and hole radius equal to 15. Okay, let's do that. So else, open the bracket. First of all, fillet being present equal to true. Let me go to the next line here. Okay, equal to true. Enter. Then we go to hole to be true. True. Enter. So radius of the fillet to be equal to, why don't I make it 20 millimeters? How about that? 20 millimeters. And diameter of the hole to be 40 millimeters. How about that? Yeah. 40 millimeter. Close the bracket. Make sure there are no syntax errors. You just click on this to see if there are any syntax errors here. Okay, I see right here. Let's find out why. There's obviously a problem right there. So let me check that again. Syntax error line 17, per DH cannot be used. Oh, in this context. Oh, this should be, sorry, this should be F. What did I call rename parameters? Oh my God, this was DH. This was supposed to be DH. I made a mistake. That's okay. So let me go and fix the diameter of the fillet doesn't make sense. Okay, so let me close that. Let me close that. Say, okay, I know that. Do you want? Okay, that's going to cause a problem for me. So I'm going to say no. Okay. We have to fix this. Okay, so that's all right. I made a mistake in naming this thing as df. Should have been dh. Or click on f of x. Click on that. Where is there is a hole radius. Hole. This thing. I wanted the h. No problem. I mean, things like this happen. Good. Now we go to there. Okay. And this should be df. dh. Where else? I don't have any other DHs, DHs, DHs. Good. So let's check it now. No problem. Apply. Okay. So, okay, let me activate this. Right click, activate. or Control U. This thing is deactivated. I didn't want it to be deactivated. Oh, activate, right there. Good, good. Okay, so let's go ahead and plug in the values. We go to f of x. Let's go back to f of x. Here is the value of L. Why don't I make L 90? And I make W 40. So if you look at that, if L is 90 and W is 40, there should be no hole, but there should be a fillet of radius 5 present. So let's go back here. No hole, fillet of radius 5. Is that correct? Let's check. And it looks okay, but here's what I'm going to do. I'm going to say, okay, let me go to part design. I'll do the same thing from part design because I have a caliper there. I can measure things. You go for part design and double click on this. Oh, it sends me there. Okay, so let me see now. Can I measure stuff here? Okay, so let's go back to part design. The fillet radius should be 5. So part design. Get the caliper. Where's the caliper? Measure. It's somewhere here, right there. Measure. Okay, notice that this better be 5. It is 5. You can see that. Okay. All right. Let's go ahead and do more. Say okay. Click on f of x. Let's change it. L equal to 120 and W equal to 50 or 60. Apply. There should be no hole and no fillets because where are we? With these values, we're in this range, no holes and no fillets. Let's go and try this one. Let's make L equal to 120. There should be no hole, no fillet, and a hole present. So let's go here. Let's make this thing 50. This should be, or 40 actually. This 40. There should be no fillets. What a hole. And uh, the the diameter of the hole should be 30 millimeters. So let's check. Let's check. Let's go back here. Get the caliper out. This should be radius 15 or diameter 30. Yeah, radius 15. Okay. So it is working. Now, the only thing I want to do is to check, for example, to check what happens if I put uh, L equal to 120, but W equal to 50. That's the last line of that portion of that module. Apply, and then we say okay, because look at what happened. When W is 50 and L is 120, so essentially I'm dealing with this situation. Let's go back here. Let me close that. These numbers that I put in there will go and fall into that category. And that's why the radius of the fillet is 20 and the diameter of the hole is 40, 20 and 40. Let's go check it out. We go back to part design, get the caliper out. This should be fillet radius 20, and it is. And this should be the diameter of the hole 40, and it is. Radius is 20, diameter of 40. Okay, folks, I kind of uh, mumbled through this, but I essentially at the end decided to do something about that case, L equal to 50 and or W equal to 50 or L equal to 120, or equal to 100 and added this last piece and it works fine. Okay? Uh, Good luck.